as well. So a little background on David before I hand it over to him. As you know, he's a software engineer, programmer here at NCAP. And looking at his bio, he goes way back in this area to his birth. He's a Boulder native. And so a little on his educational background, he got his bachelor's in science at CU Boulder in computer science, and has been been a part of this organization. Was a student assistant in RAL starting in 1999, working with the 4D weather project, and where he developed web applications as well for CMIP data and did a hydro inspector to show river stage and flow rate observations with model data on top. So ever since then, he's been at the cutting edge of cool technology for geosciences. He's worked at STAR, GACDSA, Cosmic, and RAL, and still with us at RAL. At STAR, he was the lead engineer for the Pentagon Shield, an urban scale transport and dispersion system used by emergency responders around the Pentagon and DC area. At JCSDA, he helped get FE3 on Amazon Weather Service and used CloudFormation to start cluster and resources before Parallel Cluster existed. At Cosmic, he developed a serverless web application to display the radio occultation datasets collected from Cosmic 2 Spire and other missions. And at RAL, he is known for a number of his projects, including the WRF Cloud Hurricane Risk Calculator with Jonathan Vai, and what he'll talk about today, the serverless web map service, WMS. And so I think I'll hand it over to you to tell us a little more about that.
All right, thanks for the introduction. So I'm talking about the micro web map service today is what we're calling it. I worked on this with Patty McCarthy, who's another software engineer in RAL. We did this under the RAL Opportunity Fund, so we got some funding to make this a reality. So what this is a cloud-based microservice web map service implementation. So, and I'll get into what that means. So the vision for this project is that you have boundless web map service capacity. You don't have to manage any servers, and you only pay for the compute and storage that you actually use rather than what you've provisioned. So almost sounds too good to be true. So backing up for a second, I'll want to define a few terms so for people who aren't aware. So what is a web map service? This is a tool that we use a lot in our application development for rendering gridded data that we can overlay on a map. So what a web map service does is it generates small map tiles from your data that you can put on top of a map to georeference it. It's an open geospatial consortium standard, and there's a few implementations of it that we commonly use, like Threads Data Server and GeoServer. But those have been difficult to deploy in a serverless environment to get some advantages. So the other key term is, what does serverless mean? So each of these columns here represents a different service level for cloud services. So on the left side, you have the on-premises. That means you're not using any cloud services at all. You're managing everything yourself. You buy your own hardware, you set up your own network, internet connectivity, server rooms. You have to do the operating system management, the virtualization, install your own runtimes, as well as managing your own data and your applications. As you move to the right in this diagram, the cloud service provider is going to be managing more of these aspects for you. So infrastructure as a service, that would be, an example would be getting an EC2 server. So you tell the cloud service provider you want a server, and they give it to you, and from there, you have to manage the operating system, your runtimes, and your data and your applications. One step over to the right is kind of where we try to fall into the serverless designation. And in there, they're managing the operating system and the runtime for you as well. So you can tell them that you want a web server, and here's my content that I want hosted. You can tell them you want a Python 3.13 environment to run this function when I invoke it, and they manage all that for you. They find the hardware to run on when it's needed, and generally you pay for what you use, not for what you provision, like you would under infrastructure as a service. And then software as a service would be somebody else is developing the application and you're using it, like we're using the Google Slides right here. So we took those two concepts of the web map service and serverless and combined them. So we have the micro web map service. So basically how this works is the web application or a desktop application on a laptop, a user's laptop, will send a request to a web server saying they want an image to put over this on this map overlay. And that request is going to include things like the geographic region, which field they want, which meteorological field, the vertical level, the map projection, which color palette you want to use, the min and max values. So that whole request is going to get sent to the API gateway. The API gateway in our case doesn't do much, but just pass along the request to a Lambda function, which is our Python code that gets executed. And it has access to that request. So our Lambda function is going to look at those parameters, figure out which data it needs to read from the S3 ZAR store, render a georeferenced image, and then return it to API gateway, which returns it to the client. And the client puts it all over the map so the user can see the data over the map. So some of the challenges in this were, because we're using Lambda, we have a 250 megabyte limit. So this is the list of dependencies we ended up with. And everything in bold is over 5 megabytes. I think the Pandas was over 100 megabytes by itself. So we ended up with 346 megabytes of dependencies, and we had to somehow shrink it into 250 megabyte limit to run it in Lambda. So it turns out a lot of these libraries come with data examples and test code. So we started deleting things until I kept running our unit tests and deleting things and running our unit tests again until the unit test failed, and then we put it back. So we barely squeezed it into the 250 megabyte limit. So Lambda service now does allow you to use a Docker container. The image can be up to 10 gigabytes, but I was worried about performance issues with that, so I wanted to stick with their native dependencies instead of doing that. So one of the things that we are claiming this can do is that it has great scalability. So in order to test that, we used the JMeter load testing software. And I set up a load test that has 1,000 users, and it went through 10 iterations of that, so for a total of 10,000 requests. So the JMeter software calls it a user, but it's basically just a single request. So there's 1,000 requests going on concurrently, and so it has 1,000 users making requests until 10,000 are complete. So some results of that are when we first started it up, the Lambdas are what's known as cold, meaning the cloud service provider hasn't deployed your runtimes yet and set up your runtimes. So there's some overhead in doing that. It takes a few seconds to find a server, deploy your software and dependencies in it, and start the execution. So that's cold. And then if that runtime is not or isn't used for 15 more minutes, the runtime gets deleted. But if you call it again in that 15-minute period, the Lambda is called warm, and it doesn't have to go through that first step of initializing the runtime environment and deploying your code to it. So there's a time difference there. When I first ran it and nobody had been using the system, I'm calling that the cold Lambda. So that took 53 seconds to process 10,000 requests at a rate of 188 requests per second. And the warm Lambda took 24 seconds and it handled 416 requests per second. So recently, Patty made a change in the optimization of how our code is reading the data from S3 in the ZAR store. And we got these new numbers. So the cold Lambda is finished in 21 seconds, and the warm Lambda is finished in 15 seconds. So we were handling a peak of 667 requests per second, which is pretty impressive. And that's starting from nothing. The Lambda wasn't deployed anywhere, 21 seconds to handle 10,000 requests. So just as a comparison, I point to the same load test at a server that we have running for an application here. And it took 3 minutes and 3 seconds to handle 10,000 requests. So that's 12 times longer. But it also had a 40% failure rate. Whereas the Lambda didn't have any failures. The failures were due to the server being overloaded. There were too many requests. I was actually expecting it to run out of memory, but that's not what happened. The other web map service here that I'm referencing was announced at the AMS conference last January to a room of 30 to 40 people. The URL was given out so people could try it. And the server almost immediately crashed, and I got an email saying it's not working anymore. So I had to go debug and see what happened. And at that point, it had run out of memory, and I had to restart Tomcat for it. So you can see the difference here in how much maintenance and intervention is required when you get a spike in users. So that covers the scalability. We're also saying that this is cost efficient. So on March 26th here, when I ran the load testing, I ran it several times, and we processed almost 60,000 requests total. And that ended up costing us $1.11 to handle 60,000 requests. And then you can see on the other days, the subsequent days, there was no activity at all. Maybe it was a weekend, and it didn't cost us anything. So when the system's idle, nobody's using it, you don't pay anything except for data storage that you have there. So the current status of this project is that we have implemented the git map request. The git capability is part of the OGC standard, but it's not implemented yet. Just with the git map, it's still usable by other projects. So it's possible to use it now. Your application just kind of has to know what data are available for what time period, which fields, things like that, without querying the server. So we're hoping to be able to add this when we get time to put it in, so it's fully compliant with the WMS standard. I want to discuss with the RAL management about making this open source so that we can share it with other organizations. And we have a prototype application deployed. And right now we're looking for projects who might be able to use this web map service, how it is. And I'm actually getting in the middle of deploying this for an application in Cosmic right now. These were the slides that I showed at the Improving Scientific Software Conference a couple of weeks back. So we had an audience of about 50, maybe 40 people, 40 to 50 in person and more online. So I put up the URL of our demo application, and I'll show this again later if you don't want to look at it right now, but you can. But, yeah. And if you type it in, you have to type the www or it won't work. All right, but now I'm able to share the results of what happened at the Improving Scientific Software Conference. So we ended up getting almost 11,000 requests from 32 different users. The average response time was 600 some milliseconds. The fastest one was 450 milliseconds. And the longest ones were 6.8 milliseconds. There were only 336 that took longer than a second. And I believe those were probably the cold Lambdas where Amazon was deploying the runtime environments for us. And then after those were deployed, it went much faster. So we were receiving those requests over a period of 9 minutes, and in that time we used almost 2 hours of compute time. And to handle all of those requests, we spent about 16 cents, so not including the data storage. So I added this slide after that presentation, of course, just to show the results for future. So why would you want to use the micro web map service? So we've gone over scalability and cost efficiency. It's also low maintenance. It's a serverless architecture, so we don't have any servers to reboot. We don't have to reboot web servers. We don't have to manage the operating system. We don't have any visibility into that. The cloud service provider does that for us. And with micro web map service, the design of the API is also extensible. So I actually have more details on that. But, so for scalability, traditionally when we're planning a project, if it's public facing, we have to estimate how many users we're going to have, and therefore how many servers we need to handle peak amounts of traffic. So with the serverless architecture, we don't need to do that anymore. If you decided you needed more than one server, you'd want to set up some kind of a load balancer to route traffic between your compute nodes to handle it. You don't have to do that anymore. API Gateway handles that for us. And of course, those are all just estimates in your planning, so it's going to be not going to match reality 100%. So you're either going to have idle compute time or not enough compute time. So we don't have that problem anymore either. So just to kind of illustrate how this works with the Lambda service, every time your code is invoked, it's going to, Amazon is going to go out and create a runtime environment. So here we told it we're using Python 3.13. So every time we invoke the function, it creates a new Python runtime environment. You can do that many, many times. I think the default account limits allow you to run 1,000 concurrent functions, and you can contact their support to change that to increase it if you need to. And then if the runtimes sit there for 15 minutes and they're not used, you don't pay for it, but they'll go away automatically. And then that's kind of what I mean by the function going cold. So the cloud service provider needs to create the runtime again when the function gets invoked again. There's a few seconds of overhead to set that up. So, and then for the low maintenance, as we talked about, we're using the platform as a service level solutions from the cloud service provider. So we're relying heavily on API gateway, which basically replaces the web server, which would be Apache or Tomcat in most of our cases for projects in RAL. So we configured an API gateway distribution to assign api.wms.ral.ucar.edu to it. So any requests going to that URL are going to get forwarded to our Lambda function. That'll include the full WMS request going to our Lambda function. The Lambda figures out which data it needs to read. It renders an image and returns it back to the client through API gateway. But as you can see in the platform as a service, we don't have to manage the runtime, that being Python or the web server. We don't have to manage operating systems, hardware servers, any networking. We also have the benefit of these being deployed across multiple availability zones when you put it into one region. So if AWS has hardware issues or network outages, they move it to a different availability zone that doesn't have these issues, and you don't have any downtime. So as long as I've been working with these, I've never seen any downtime with them at all. So for cost efficiency, you pay for what you use only, not for what you provision. So Lambda functions are metered to the nearest 100 milliseconds, and you pay 1.3 times 10 to the minus fifth dollars per second. API gateway, it's also a very small charge for per request. And then for the S3 data storage, you pay 2.3 gigabytes per month. So that's probably the largest cost if you have a lot of data you need to store. So, and then the other benefit of this API design is that you can add new functions to it pretty easily. There's one class called action, and you can implement the action class and override the two methods in it. Validate request that looks at the request parameters, make sure it has everything it needs, sanitizes the data to look at it, and then perform the action, which in our case, the get map renders and retrieves data and renders an image and returns it. So if you wanted to add like the get capabilities, you would do that the same way. If you wanted to make this a feature service, you could add a get feature action in there, and that could query another database that you have. And the way the API is designed, we can also apply authorization and authentication to it. So it doesn't necessarily have to be open to the public. So current uses, maybe the slide is a little bit ahead of myself. I'm in the middle of deploying it now. But we're using this for the CDAC GNSS-RO dashboard. And if you fully expand that acronym, that's what it is. I don't think we have time to read it now, but it's in the slides if you want to go back and look at it later. So for this project, we're going to be using the micro web map service to display the global cloud satellite mosaic. And we have 5 different fields for that. We have the water vapor, visible, long wave and short wave infrared, and the surface solar radiation. So that's a data set that NOAA is putting together already, so we're just making use of that and pulling it into the system. So I always feel like there's very few one-size-fits-all service or one-size-fits-all solutions. So a case where you might not want to use micro web map service is if both of these 2 conditions are met. If you have low user traffic and you have a lot of data to store, it might not be a good fit. I put a table over to the right, so you can see kind of what the data storage costs are. But you might want to try to balance that with expected maintenance on the system versus your data storage cost. So it would be up to the project to figure out which one's better for them. So here's a current list of RAL projects that are using web map services. I think most of these are using Threads data server or maybe GeoServer. But these are all potential candidates for moving over to the micro web map service if it makes sense. So I guess I won't read them all, but there's some screenshots of them. Some have been around for a long time and others are still under current development. So yes, the kind of shows that the web map service has been a very useful tool for us for developing lots of applications over the years and still continues to be. With this project, we're just trying to kind of update it so that it can be deployed in cloud easily and take advantage of what they have to offer. So here's the URL again for the our demo application. It doesn't do a whole lot. It's just a single pressure level, single time step from Hurricane Milton last fall, but you can zoom around and you can pan the map and zoom in and zoom out. So, so I'll take any questions.
Thank you, cool stuff. Wait, is this on?
Yeah.
All right, we'll take questions.
Great work. The styling of the layers, how much have you implemented of the full capabilities in WMS regarding color scales and contouring and other rendering styles?
So we're able to change the color scales, so you can tell it which palette you want in the request. And then as far as styles, I think we're just doing like the box fill. So we haven't done a lot of that, but do your projects have needs for other styles? Or
Occasionally, yeah.
Yeah.
And
What
is
do
this
you-
like NCDF backing data?
Yes.
Or in a single projection, or do you have full projection?
we can change the projection.
So you talked a lot about applications on AWS. Is it transferable easily to other platforms or even local platforms like Derecho?
I don't think it would be applicable to Derecho. So a lot of the major cloud service providers like Google and Microsoft Azure, they all have similar offerings, but there's a lot of detail in getting it set up correctly. So right now we only have it on Amazon. That's what most people here use. We've always gotten really good support from them. We have people, so I have like 3 or 4 people I can call at Amazon for different questions. And we never really got that level of support from the others. And I think that was a big factor in why everybody's using Amazon. So I think it's technically possible to deploy it in other cloud service providers. With it would take a little bit of effort. So right now we're setting up all the resources with CloudFormation. It's known as infrastructure as a service. So we just kind of configure all the resources that you need in a YAML file, and then Amazon takes it and deploys your resources and connects them together. So they all have similar offerings, like the function as a service, an API gateway, but it would take a little bit of work to get it deployed to other cloud service providers.
Thank you. So with the requests, with the WMS requests, is it just a standard WMS request that you put in? So I was just wondering, like, you know, with QGIS or ArcGIS, we can access a WMS server just by putting in those parameters. So I was just wondering if everything would be the same with this, with the same types of parameters and value pair.
Yes. So I tried to. So our demo application is in open layers. So we're just using the standard WMS tile layer. In that, as far as QGIS, the first thing that does is makes a get capabilities request, which we haven't implemented yet. So I tried that. But I think once we have the get capabilities implemented, it should work. So it is following the OGC standard. So.
And then my second question is, like you showed the climate inspector, and a big thing with that is, yes, we can see the map, but we can also click on the map, and then, we do an open data request to get information back. Is something like that possible through this architecture as well?
Right now, we're just rendering the tiles, but you could do it through this architecture. So in Climate Inspector, when you click on it, the client side in the browser translates that click to a latitude and longitude and then asks the server for that data. So you could extend the API to say that you can add a request in there to get point data for like a time series. So I think that's what we did for Climate Inspector as well. We didn't use the web map service for that or any part of threads.
And so would that be just another like Lambda function that you would put up there, or would that be in the gateway API part that you would do that?
Yeah, it would be part of the Lambda function, so we would extend this action class to do, we would create like a get time series data or something like that. It would extend this action class and then implement these two functions. And they would have to know how to access the data and return time series data for a given point.
Oh, I'll read it.
Okay, sounds good. No. Thank you.
Nice project, David, Patty, which I say too. I'm curious what is involved in loading data. Can it load vector and gridded data as long as they are in netCDF converted to ZAR?
Let's see. So Patty handled a lot of the data ingest steps, converting netCDF data to ZAR. So we used a WRF output for our example. So the gridded data, yes, you can convert those. As far as the vector data, I'm not sure about that. I'm not sure what an example would be.
I was going to ask, like, so my question, which is kind of follow-up, like we have a project perhaps in Ethiopia, a operational hydro forecasting project. I asked Andy Gatos, hydro inspector, and you came back and said, from an operational standpoint, I'm a little bit nervous. What are your thoughts about, vector data, right? Hydrologic data is vector data, not necessarily gridded, so.
Okay. Yes, I think that would be kind of like a web feature service.
Yeah, you mentioned.
So I think that's I don't think that's part of web map service standard, but others applications like GeoServer and Threads Data Server do implement that. So that's something we could also add to this framework.
And could we set it up in Ethiopia?
Yeah. Yeah, you can pick AWS regions around the world, so whichever one's closest.
All right, forgot to wear my glasses today, so I'll have to go close to this. Okay, Rajesh mentions, or says, great talk, David. What would be the cost to sustain a dashboard after a project ends? I'm asking for projects that operate on a 3-year cycle, and continuity is not always guaranteed. Great question.
Well, if nobody's using it, you just pay for your data storage at 2.3 gigabyte or 2.3 cents per gigabyte per month. So I'm not sure what you mean by ends. I mean, there's no more funding to support it, or nobody's
I
using
think so,
it anymore.
Yeah, that's the typical NOAA
Okay.
cycle.
Well, it's going to depend on user activity. So that's one of the tasks we get to eliminate now is the capacity planning. Of course, you still need to do that to make sure you have a budget, I guess. But I think within the 3-year period, you'd be able to see what your average monthly costs are, and if your usage is going up or going down, you'd see trends in it. But it's really going to depend on how many users you have, because we don't provision any compute time. If nobody's using it, it only costs you the data storage.
Yeah, I mean, I had a similar question. I was thinking like we do projects with the Hurricane Center where we just provide experimental data to the forecasters. This seems like an ideal platform if it's cost effective, because you're compared to like transferring stuff over to their servers and so forth. So
Right.
that would be relatively low traffic and very episodic, like during the hurricane season. Would
Yeah, that's right.
still be cost effective then?
Yeah, definitely. Yeah, I think this is great for things that are seasonal, like wildfires and hurricanes, floods, lots of different things. But yeah, because you'll end up with times where you have a spike in users and other times where it's not used. If it's not getting used, you don't pay anything. If you get a huge spike in traffic, this will scale to meet the needs of all the users.
Cool. And just one other question. Lambda was maxed out at 250 gigs. What if you have you necessarily need more than that? Is there a different option, or are you kind of stuck in the situation?
Well, it's 250 megabytes, not
Or
gigabytes.
megabytes. Yeah.
We don't think in megabytes anymore.
Yeah.
Yeah, so you can use a Docker image up to 10 gigabytes. I was worried about it on this because we need a fast response for the user. So I was worried about performance. I've never actually tried it to see how it performs.
Okay, we also have a question online by Andy Gatos. Have you tried running this using a Docker image in Lambda? And if so, how does the performance compare to a discrete Lambda function? If not, what is the expected performance hit?
So I have not tried deploying this in a Docker container in AWS. I have run it in a Docker container on my laptop. The performance was pretty similar. I think my laptop was a little bit slower than what AWS was giving me. So I mean, yeah, that's why I spent time cramming this into 250 megabytes, because I was worried about the performance. I didn't try it, so I don't know. But I have not tried it.
Oh,
Hey, David. Yeah, good talk. I think you mentioned it, but can you just go over again how you upload the back-end data into S3?
Yeah, so Patty handled most of that. I'll try to explain what I can, but he's using Xarray to read the netcdf file, and then using the ZAR and S3FS Python libraries, he is splitting it into chunks and writing it to S3, to an S3 bucket. So,
And is that amenable to a real-time project, or is this generally data that's going to sit there for a while?
you can do it in real time. Patty gave a talk about 3 or 4 weeks ago that goes into a lot more detail on this. It was part of an AWS tutorial series that we did. Patty and myself and Victor Weeks all gave talks during that. There was like a 7 or 8 week session, and the last one was Patty's talking about ZAR and how to upload it. So send me an email if you want the location of that if you don't have it already. But those were recorded, so you can go back and watch it.
Great. Thank you.
One of the limits with Threads data server and GeoServer is the time handling. Never seems to be handled very well. Does your implementation do any time handling? And if not, what would be the level of effort required to add that for a real-time system, the way Mike suggested?
Yes, so part of our request is the date and time. So it uses that parameter to look in the ZAR store to get the right date and time out of it. In the talk that Patty gave about S3 and ZAR that I mentioned, he goes into some detail about how you can update it in real time. If you have a data set that's like constantly growing, you have to do something different with it when you initially create the ZAR store. But yeah, I think there's details of that in his talk as well. So I'm not as familiar with him, so I can't talk about it too much.
Okay, any other questions? If not, I just, let's thank our speaker again for the very informative talk. And hopefully we know where to find him, so I see a lot of potential here for collaborations.
Thank you.